In this video, we are going to explore how to write algebraic expressions from real-life situations. Let's begin. So mathematicians can represent real-life situations using expressions and equations. An expression, if you remember, is a mathematical statement. An equation is a mathematical statement with an equal sign. So equations are made up of two equal expressions. So let's take a look at these questions right here. Are the following examples examples of equations? So 2 plus 2 plus 3 equals 5. Is that an equation? Well, it does have an equal sign. So yes, it is. Is 5 plus 1 an equation? No, it is an expression, but it's not an equation because it doesn't have an equal sign. What about 10 equals 16 minus 6? Yes, it's got an equal sign, and the two sides are equal, so that is an equation. What about 1 plus 2 equals 9? Now, it seems like it would be because it has an equal sign, but it's not because 1 plus 2 doesn't equal 9. It's 3. And so this would be not a true statement. It's not an equation. How about 3 plus 1 equals 7 minus 3? Well, that's 4, and this is also 4. So yes, this is an equation. And 1/2 equals 0.5. Yes, 1/2 and 0.5 are the same thing. So yes, that is an equation. Let's continue. Algebraic equations are equations with variables. A variable can represent a number. Sometimes they can even represent more than one number. So the only difference between an equation and an algebraic equation is that, there's no difference. An algebraic equation is a kind of equation, and it's a kind of equation with a variable in it. So in an equation, we want the expressions on both sides of the equal sign to be equal. Usually there is more than one way to do this. All right, let's look at our first example. Min gets paid $2 more per hour than Kai. How much does Min get paid per hour? So if we see a little seesaw right here, we like to think of an equation as something that needs to be balanced. The thing is that it's an equal sign in the middle, and we want both sides to be equal. Now, in our example, in our story, Min gets paid more than Kai. So you can see that Min actually, because Min gets paid more, it's heavier on Min's side. So how do we balance it out? How can we make Kai and Min's hourly pay equal? Well, one way of doing this is to add more to Kai's pay. So let's say we added $2 more to Kai's pay, like plus 2. Now, the seesaw would be equal. What's another way of making this balance? Well, let's take a look at this picture right here. What I do to Min's pay? Well, I took off some. How much do you think? Well, it's 2. So I can also subtract $2 from Min's pay, and now their pay would be equal. So equations, with an equation, you're trying to balance both sides of the equal sign. And when you write an equation, you want both sides of the equation to be equal. We're going to say this again and again and again and again. All right, let's continue. Min is paid $2 more per hour than Kai. Well, we already knew that. If Kai makes $15 an hour, how much does Min get paid? Now we know how much Kai gets paid. And I know many of you are thinking, like, I already know the answer, so what's the point? Well, we want to write an algebraic expression for this story because that's the purpose of today's lesson. So write an algebraic equation for this story to help find out how much Min gets paid. So the plan is, what is the plan? Well, we know that Kai's pay is equal to, if you add $2 to Kai's pay, it'll be equal to Min's pay. So Kai's pay plus $2 is going to be Min's pay, equal to Min's pay, kind of like right there. Or you can say, well, you can take Kai's pay, and that's going to be equal to Min's pay minus 2. So you can add 2 to Kai or take $2 away from Min. So how would you write this as an algebraic equation? Well, you just take Kai's pay. Now, do we know what Kai's pay is? We do. It's $15 an hour. So we're going to replace Kai's pay with $15. And we're going to bring down the plus 2, bring down the equal, and then we're going to need to put down Min's pay. Now, do we know how much Min gets paid? It says, how much does Min get paid? We don't know. That's going to be our variable because we don't know what that answer is. So we're going to write M for Min. Now, you could have used any variable that you wanted to, but I figured M would make sense because it's Min's pay. Or if you wanted to write an algebraic equation from this right here, you could just say Kai's pay, which is he makes $15 an hour. Bring down the equal sign, Min's pay, which you don't know. So that's going to be our variable M, and bring down everything else, which is minus 2. So last question, what does this variable represent? Well, the variable is the M, and it represents Min's pay. So M equals Min's pay. All right, example 2. By the way, you can pause at any time to try these yourself. I'm going to keep going. Daniel was buying food for his son's birthday party. He spent $50 on pizza at the pizzeria. Afterward, he went to the grocery store to buy 8 cases of soda and water. By the time he got home, he had spent a total of $64. How much did Daniel spend on drinks? Write an algebraic equation for this story to help find out how much Daniel paid for drinks. Well, fill out the boxes on the seesaw. What are the two things being balanced? Well, he bought pizza. The cost of the pizza plus the cost of the drinks should be equal to what? Should be equal to the total cost that he paid. So our plan is to do what with the pizza and the drinks? Well, we're just going to add them up. So pizza cost plus drink cost should be equal to the total cost. How else can we solve this? Well, we could say that the total cost minus the pizza cost is going to equal the drink cost. So let's say you were trying to figure this out and you're thinking, how do I do this? Well, if you take away the pizza cost, it'll get you the drink cost. Anyhow, let's turn this into an algebraic equation. Pizza cost, do we know how much the pizza cost? It says he spent $50 on pizza. So yes, so replace pizza cost with 50. Do we know what the drink cost is? We don't, because that's what the question is. How much did he spend on drinks? So we don't know what it is. So we're going to put plus and then drink cost, which I'm going to use D as my variable. 50 plus the drink cost is going to be equal to the total cost. Do we know what that is? We do. He spent a total of $64, so 64. If you were going to write an algebraic equation from this plan right here, you would write the total cost, 64, minus the pizza cost, which is 50, equals the drink cost, which is unknown, D. So what does the variable represent in our equation? Well, D represents the drink cost, so D equals drink cost. All right, let's move on. You can try number 3 if you'd like. I'm going to keep going. Eli bought a book. The price of the book was $22. He had a $5 coupon and paid for the rest of the book with cash. How much cash did Eli use to pay for the book? Write an equation for the story to help us find out how much Eli paid in cash. So we know that the cost of the book was $22. So if you pay for a book, if he paid money plus $5, that's going to equal the total cost of the book. So we can say cash plus coupon equals cost of the book cost. Or you could say, the book cost minus the coupon is going to get you how much he paid in cash. Anyways, how much did he pay in cash? Do we know? Well, we don't. That's the question. So we're going to replace that with a variable, C, plus the coupon, which is a $5 coupon, equals the book cost. We do know what that is. It is $22 for the book. So it's C plus 5 equals 22. Or book cost, 22, minus the coupon is going to equal how much he paid for in cash, which is C. And what does a variable represent in this situation? Well, the C represents Eli's cash. Let's move on. Nadia runs a few miles each day to train for a marathon. Her brother Mick runs 1/2 of that distance because he's training for a half marathon. On Monday, Nadia ran 14 miles. How far did Mick run? Write an algebraic equation for the story to help us find out how far Mick ran. All right, in this multiplication division example, we will use a table to demonstrate how to set them up because the seesaw analogy doesn't really work as well. Anyhow, let's look at this table. We have Mick's distance and then Nadia's distance. So if Mick ran 2, then how far did Nadia run? So if Mick ran 2 miles, Nadia ran, Mick is only running half of Nadia's distance. So if 2 is half of what? Well, it's half of 4. If Mick ran 3 miles, then Nadia ran, 3 is half of what? It's half of 6. Right here on this table, if Nadia ran 10 miles and Mick ran how many? Well, he only runs half of Nadia, so half of 10 is 5. And then what if she runs 12 miles? Well, half of that is 6. Anyhow, in an equation, we want the expressions on both sides of the equal sign to be equal. Therefore, we want Nadia and Mick's distance to be what? Equal. That's right. And we can do this in 2 different ways. We can make Nadia's distance equal to Mick's. So we can make her distance equal to Mick's by basically just dividing her distance by 2. Now, what can you do to Mick's distance? So if we want to make Mick's distance equal to Nadia's, what would we do to Mick's distance? Well, we could multiply multiply it by 2. Now, above we said we can make Nadia's distance equal to Mick's by dividing it by 2, or you can multiply it by a half, which is basically going to do the same thing. Anyhow, what is the algebraic equation? Well, the question was, how far did Mick run? So that's going to be our variable. Well, we can make Mick and Nadia's equal by saying Mick's distance times 2. So 2 times Mick's distance is going to equal Nadia's distance, which in this case is going to be 14 miles. So that's our equation. Another way you can write this is instead of 2 times m equals 14 is 2m equals 14. And this is actually the preferred way to do this. So you may want to circle that because 2m is just another way of writing 2 times m. And the reason we don't like to use the times is it looks too much like an x. It looks too much like a variable. So this is the preferred way of representing multiplication when you're multiplying a variable and a number. Anyhow, what's a variable represent in our story? M represents Mick's distance. Anyhow, let's continue on. Question number 5. Miguel went out for lunch. He ordered a cup of soup for $2.99 and a salad for $4.49. The total cost of his food, including the sales tax, was $7.76. How much was the sales tax? So he had to pay for the soup and the salad, and it looks like he had to pay for sales tax as well. So what's our plan? Well, he pays for soup and salad and sales tax, and that equals the total. So what's the algebraic equation? Well, what is the soup? The soup is $2.99, so replace soup with $2.99. Bring down the plus. Salad is what, $4.49, so we're going to put $4.49 in place of the salad, plus the tax, and we don't know what the tax is, so we are just going to replace it with a variable. I'm using x instead of t because t might look too much like the plus sign, and that equals the total. And the total, do we know the total? We do, it's 776, and that's our equation. What does a variable represent in our equation? It represents the tax. All right, example 6. Monica bought a box of ice cream bars for $14.99. The box contained 24 ice cream bars. She brought them home, and by the end of the day, only 7 ice cream bars were left. Wow, a lot of people ate ice cream bars. How many ice cream bars were eaten? We're going to write an equation to figure out how many ice cream bars are eaten. So she spends $14.99 for it, but that doesn't seem to have anything to do with it because it has to do with how many ice cream bars she had. So she started out with 24, and by the end of the day, she only had, and a bunch were eaten, and then she had 7 left. So what is our plan? Well, we have our total amount of bars, our initial amount of bars, and we're going to subtract the number of bars that were eaten, and then that's going to get you how many bars are left over. Do we know the total bars? We do. It's 24. Minus the number eaten. We do not know the number eaten, so I'm just going to replace it with an e. Bring down the equal sign. The number left, do we know how much is left? Yes, only 7 were left. So 24 minus e equals 7. So 24 bars minus the number eaten equals 7. What's e represent? The number of bars eaten. All right, we've got 3 more examples. Number 7. Laura rode her bike at a pace of 12 miles per hour. By the end of the day, she had ridden 108 miles. How many hours did she ride her bike? So she rides 12 miles per hour. That's how fast she's going. Now, if she rode 12 miles per hour, that means she's riding 12 miles every hour. So after 1 mile, she rides 12 miles. And after 2 hours, she's ridden 24 miles. 24 miles. And after 3 hours, it's 36 miles because it's 12 and another 12 and another 12 and another 12. Every hour, it's another 12. So it's like multiplication. Repeated addition is multiplication. So it's speed. By the end of the day, she had ridden 108 miles. So 12 miles per hour times the number of hours she rode, which, we don't know yet, is going to equal how far she rode total. So the speed times the hours ridden is going to be the total miles. The algebraic equation is going to be speed, which is 12 miles per hour, times the hours ridden, which we don't know. So we're going to replace it with the variable h equals total miles. Do we know the total miles? Well, by the end of the day, she had ridden 108 miles. So yes, we do know the total miles. So 12 times h equals 108, but we don't like it written like this because it looks too much like an x or a variable. So we do 12h equals 108. You may want to circle that as the preferred way to write this. And the variable h is the number of hours ridden. All right, Alexi, example 8. Alexi bought a roll of leather cord to make bracelets. He cuts the cord into 9-inch strips to make a single bracelet. He was able to make 20 bracelets with no leather left over. How long was the original roll? Okay, so we have this long roll of leather cord, and it's almost like a ribbon or something on a spool. You just pull it and you just cut into pieces. So he cuts them into 9-inch strips, and he was able to get 29-inch strips with nothing left over. So what kind of operation is that? Well, we take our original roll and we're going to cut into 9 equal strips, equal 9 into equal 9-inch strips. And that's going to get us 20. So we're going to divide it by the bracelet length, which is 9 inches. And then that's going to get us the number of bracelets. So let's say, let's continue. Do we know the total cord length? It doesn't say. We just know that he cuts it into 9-inch strips. So we don't know what that is. I'm going to use C for my variable. We're going to divide it by the bracelet length, which is 9 inches for each bracelet. And then the total number of bracelets, we do know that. So it's going to equal 20 bracelets because that's how many he made. And that's it. Now, the preferred way to write division actually in an equation, the way you'll see it most often is going to be division in the form of a fraction. So this says C divided by 9 equals 20. This also says C divided by 9 equals 20. And what does the variable represent? Well, C represents the total cord length that he bought at the beginning. Last one. Mr. Johnson dropped his son off to school in the morning and drove back home. In the afternoon, he drove to the school again to pick up his son and drove back home. He drove 5.2 miles total. How far does he live from school? Write an algebraic equation for the story to help find out how far he lives from school. So he drops off his son at school, then drives back home. And then he drives to school again to pick up his son, and then he drives back home, and that's a total of 5.2 miles. So our plan is that you're going to have the distance to the school, and you're going to multiply it by 4, which is the number of times driven. So distance to the school times the number of times driven is going to get you the total distance driven. Now, do we know the distance to the school? We don't, so I'm just going to use D. Do we know the number of times driven to school? Well, he drops off his son and then goes back home. Then he goes to school again, and then he drives back home. So how many times has he ridden that distance? He's driven it 4 times, not just 2, because when he goes to school and comes back home, that's 2 trips. It's going to school and coming back home. So it's the distance to school times 4, not times 2. Anyways, that's going to equal the total distance, which is 5.2 miles. So 5.2. So D times 4 equals 5.2. And you may be thinking, oh, that's right. There's another way we can write this. It's 4D equals 5.2. And in this case, the variable represents distance to school. Anyhow, that is how you write equations from real life examples, and you could then use those to solve it. I know many of these were really simple examples, and you felt like, well, I don't really need an equation to do this, and you're probably right. But it is important to be able to write equations from stories. So go ahead and try some on your own. Good luck.